going to be Nikola, and he's going to talk about how, when, and why Clojure.
So hello, and welcome to this talk about Clojure. So my name is Nikola, and I really like computers, and I'm also incidentally the CEO of a small company called Neutrino, where we mostly build software for the web. So first of all, standard raise of hands, because speakers love that, and the crowd really loves to undermine their efforts. So come on, work with me here. So how many of you have heard about Clojure? Nice. And how many of you have tried it or used it or anything since? Okay. Okay, so I hope this talk will be very useful to the part of the crowd who hasn't used Clojure yet, and at least somewhat useful to the part of the crowd who's played around with it a bit. Okay, so first of all, this guy. I put him here because, except being the father of Lisp, which is a decent thing in itself, in about 3 weeks it'll have been 3 years since he passed away, and it's not exaggerating to say that without him this talk wouldn't be here today. But why am I talking about a language called Lisp in a talk about Clojure? Well, it turns out that Clojure is a Lisp, or more precisely, it's a dialect of Lisp. So there's no single canonical Lisp anymore. Right now we use the term Lisp to refer to a whole family of languages which share some common traits. And along with Clojure, there are many other Lisps which may be better known to you, like Common Lisp, Scheme, or eLisp, AutoLisp, whatever you might have used earlier. So yeah, although there's not a single canonical Lisp anymore, there are some standards like ANSI Common Lisp and R6RS, but that's beside the point. We're here to talk about Clojure. So it's not too hard to recognize a Lisp when you see it. Most of Lisp shares similar syntax, or as Lisp people like to call it, the lack of syntax. So let's say you'd want to define a function adding 2 numbers in a Lisp, and completely by accident, in this case Clojure. You'd define a new function saying called add 2 numbers, accepting 2 parameters, x and y, and you'd sum them up. Along with a relatively strange parenthesized syntax, you'll also notice the common Polish prefix notation. So here, the plus operator isn't an infix operator like it would be in plenty other languages. It's a prefix operator. And another thing you may notice in some newer languages, for example, if you use CoffeeScript, here again we have an implicit return. So there's no return statement in this function, yet if we call this function, this will get returned. So the last line of the function is always an implicit return. And another thing, which is kind of more of curiosity than relevant for this talk, is that Lisp allows you to use all kinds of strange characters in your symbol names, which you might have seen earlier. So you can use dashes, you can use asterisks, you can use question marks, and actually it's pretty common to do so in day-to-day code. So, other than it being a Lisp, obviously, Clojure is a Lisp for the JVM. This means that you run your Clojure code pretty much in the same environment as you run your Java code. And in fact, as an end user, you'd have to try really hard to figure out that a piece of code has been written in Clojure rather than in Java. I mean, Clojure code can be packed within jars and can use all of the Java standard libraries. There are also official versions of Clojure for the CLR and ClojureScript. We won't be talking about those too much today. We'll just talk about the JVM version. But if you're inclined to write JavaScript applications in a language almost identical to the one we'll be discussing today, I strongly encourage you to check out ClojureScript, which is the JavaScript version of Clojure. So Clojure is a compiled language, because it obviously runs on the JVM, so it has to be compiled to JVM bytecode. Usually, when you do REPL stuff, so when you play around with the language, it happens on the fly. You don't have to do anything specific. So when you load a file, in the REPL, or when you write your function in the REPL, as soon as you hit enter, the code gets loaded, compiled, and runs into the JVM. Of course, if you insist, and you sometimes usually do, ahead of time compilation is available for Clojure. And considering it lives within the JVM, like any good guest, Clojure has good interop capabilities with its host platform. So, for example, if you wanted to manipulate date and times in Clojure, and Clojure doesn't have any primitives to do that, you could just jump into Java util date and use it from within Clojure. So here we instantiate the Java util date class, and with something Clojure calls the dot notation, so this initial dot right here, we call the getTime method on that object. And the good thing is this works not only on the entire Java standard library, it also works on any third-party library you might have in your class type. So for example, if you're really thrilled with actors after Sasha's amazing talk yesterday, then you might want to try ACA, the Java library implementing actors in a similar way to Erlang. And then you could just download it and import it and put it on with the Clojure using these interop capabilities. It works. Clojure is also a dynamically typed Lisp for the JVM. So we haven't discussed types yet here, because again, it's a dynamically typed language. However, Clojure does offer certain mechanisms to remedy the lack of types. So first of which, I just, because I like it a lot, I'd like to stress out preconditions and postconditions. Now, don't confuse this with a type system in any way. These are runtime checks. So this won't happen at compile time. These are basically assertions, but it gives you a really, really nice syntax trigger to define your preconditions and postconditions for your functions. So for example, this function has a precondition of its parameter being even, and it has a postcondition of its return value being larger than 0. And this will get checked in the runtime without any further need for you to do anything. And if you try to pass it an odd number, you'll get an assertion failure at runtime, but hey. And if that's not enough for you, if you really want the type system, there's also the project called Type Clojure, which brings an optional typing system to the language. And the thing is, this is a library, so it kind of expresses the power of Lisp that you can have a completely optional type system implemented as a library in the language. Okay, so the fun part, Clojure is a functional dynamically typed Lisp for the JVM. So it's a functional language, and today many things pass for functional, and it's kind of all the rage, right? But I'll concentrate on two things. First of which is higher order functions. Now that's not the exciting one because plenty of languages have higher order functions. It's basically a fancy way of saying that your functions can return other functions, and that your functions can accept other functions as arguments. So if you used JavaScript, you're pretty much used to that. So it's frustrating. The other thing that Clojure has that's kind of sort of novel for people coming from imperative languages perhaps, is our persistent immutable data structures. So what does that mean? In Clojure, when you define your data structure, that's it. No more changes to the data structure. Any changes you do on your data structure are actually transformations of that data structure. And they return a new data structure. So the old one gets saved, and you get a new one in return. And that property we call persistence. So you'll see a lot of this when you read about Clojure. And it obviously has some interesting benefits. The most obvious one is parallelism, because if your data structures are immutable, then you don't have to worry about your threads fighting over ownership on a single piece of state. However, in that regard, Clojure is pragmatic, and it knows that it's not all unicorns and rainbows out there, because the threads do need to share state often, and it gives you a lot of interesting tools to deal with that without resorting to mutexes, semaphores, and whatnot. So just to list them, there are refs, software transactional memory, and atoms. So if someone's coming from the multi-threaded world, they'll They'll be happy to hear that. But another important, perhaps more important consequence of immutable data structures is that it's much more easier to reason about your programs. Because if you can't change state all around the place so easily as you can do in an imperative language, there's a lot less room for surprises. So Clojure kind of forces you to isolate your state changes in really small chunks of your program. And then when you have that in place, it's far easier to think about your system. And I'll just pass through this, but I had to mention it because it's a Lisp macros. So they're basically compile time transformations of your code. And 3 minutes isn't enough to explain macros, but I'll just try to give you an example. So you remember that prefix notation we've seen earlier. Well, let's say we want to do postfix notation. So this isn't legal Clojure. This wouldn't pass through the compiler. However, once we define a macro, we can transform this into a prefix notation, which is perfectly legal Clojure, and it'll just get compiled. So basically, whenever the reader, which reads your code, runs into a macro, it executes this, it passes this as is, it doesn't compile it unlike in functions, and replaces this entire thing with the return value of this macro. It's quite a powerful concept to the point where you're able to do things like racing, which is a library for asynchronous programming in Clojure, which takes to wrap your code in something called a Go block, and that transforms your synchronous looking code into this crazy state machine with continuations, which magically becomes asynchronous. Okay, so you're sold. You want to use Clojure. Just a couple of words on two really important tools. First of which is Lightstable. It's a general purpose text editor within Clojure, but it has this really nice feature of having an inline REPL. So once you open your Clojure file, so this is just a file, and you can execute line by line, statement by statement, block by block, and you'll get the output right in your text editor. This is really useful for exploring, debugging, testing, and plenty other things, and it really works with the Lisp philosophy where you spend a lot of time in your REPL just looking into your inputs and outputs and the transformations you do. And the other thing is Leiningen, which is called the easy way to use Clojure, and I like to call it the only way to use Clojure because it's really so powerful and so simple. It's basically your declarative project configuration. You tell it your dependencies, your entry points to the application, whatnot, and it does all the work for you. It can generate jars, it can run your code, it can, again, build dependencies, whatnot. And the good thing, everyone is using it. It's a standard in the Clojure community. You have a lot of templates you can use to jumpstart development of like web applications, so it automatically generates a directory structure for you, etc. So yeah. Okay, so why did we use Clojure in our company? So the motivation was a bunch of ugly PHP code doing sequential data fetching and processing from social media APIs. And that was all nice and dandy until the system got to approximately 10 times bigger than it was originally meant to. So of course the goal is to parallelize the thing because if we continued growing like that, we'd soon need far more than a single day to fetch and process a lot of data. So we had to do something. And our only requirement from the technical standpoint was to have something that can interact in any way, shape, or form with existing PHP code, because we wanted to keep a bit of control over that component of the system from the PHP side. So why Clojure? Well, first of all, easy deployment. We already had a tiny piece of Clojure code I wrote earlier, deployed on the server, and basically everything you need to deploy that into the server is a Java runtime available, so it's pretty true. I already had some basic familiarity with the language because I've used it earlier. The feature set seemed like a good fit because our problem was very parallelizable. None of the components were dependent on each other. Some people have it that easy. And we've seen the great features this primitive which allows us to parallelize that thing trivially. And it's obviously a good excuse to push some more Clojure to production, which is always a good thing. Okay, PHP interrupt. There'll be a talk about this later, so I won't mention it too much. We use 0MQ, which is a C library for message passing between threads, processes, networks. It's awesome. It has bindings for every language under the sun, probably COBOL as well. And we use CLJZMQ, which is an official wrapper around JZMQ, which are the Java bindings for 0MQ. Databases. We had to talk to MySQL and MongoDB. So for SQL abstraction, we used Forma, which was kind of standard at the time. Forma, other than handling connections for you, it gives you this more, perhaps a pneumatic Clojure way of building SQL. So this is just pure Clojure, and once you have pure Clojure, you have all of your standard abstraction mechanisms, macros, functions you can use to generate this, and that came in really handy at certain points during development. And the same goes for MongoDB, so we've used Monger, which is also kind of the standard MongoDB driver as far as I know. And the idea is the same, it just gives you some basic primitives, which are a bit more idiomatic Clojure to communicate with MongoDB. We could have used just standard Java APIs, but this is far more to work with. And of course, there are many other smaller libs we use, like something to communicate with Twitter API, CLJ-HTTP, which wraps HTTP components, CLJ-time, which wraps Yoda time. There are a lot of these on, there's a community or repository of packages called Clojures. And there are a lot of libraries already available for Clojure. And the good thing is that Clojure is hosted on the JVM, so plenty of those libraries just wrap existing Java APIs into something a bit more idiomatic. The development time was approximately 2 weeks for a single person. The result is around 1,000 lines of Clojure code, which is a really small system actually. But we got a cleaner source, better separation of concerns within the application. We got a more flexible system because now we can define fetching and processing jobs in a really clean and unified way. And of course, we've completely decoupled a really important but very tightly coupled part of our project to everyone's joy and happiness. Deployment is basically you generating a jar file out of your Clojure code, and Leiningen does that for you. It includes all the dependencies you need for deployment. You push that file to the server and you run it with something, supervisor, upstart, whatever your weapon of choice may be. Bottom line, it's a very nice and exciting and pragmatic new language. It has a really, really big, vibrant, friendly community. The people are quite smart, and they're coming from all kinds of different backgrounds. It's a general purpose programming language, so you have systems people, web people, whoever. And the language itself and the people do bring a certain novel approach to solving problems, which is always interesting. It's really easy to get going. I think it's one of the more easier languages I've had to deal with because of Leiningen. It's easy to deploy, especially if you're already running Java, and it's a really, really good first step towards functional programming. So if you're interested in the fad, so people are talking about Haskell, Camel, whatnot, Clojure, especially if you're a Java developer, is a really, really good first step towards that. And bottom line, you should be. It's not a new approach. It's been here for a while, but it's kind of gotten into the mainstream. Lately, it brings some interesting patterns and ideas to your daily programming life, and yeah, it's a shame not to. So, go build something, follow your dreams to the moon and beyond, and thank you.
Any questions?
thanks for the talk. It was good. As far as you didn't mention testing and debugging, and I believe in Java enough to not ask you about testing. But when we write concurrent or maybe just parallel systems, we sometimes have to debug this, high-load system live on production. Is there something to do that?
So if you're building a high availability system, a high concurrent system, you probably won't use the things we use, just simple futures and stuff. You'll probably use something like ALGOL or Pulsar or whatnot. I almost have zero experience with that, but I do know they have some powerful debugging mechanisms in place. So you'd probably just use what Java already offers underneath, because it's basically, most of it is Java wrappers. Now if you use Clojure primitives, so Clojure stuff like software transactional memory, I'm not sure. I'm not sure.
Hi. I work in Node.js, and there's this thing called isometric JavaScript. So the point is, you can, for example, you can write a data model in JavaScript on the server, and also pass that same code to the front end, where the JavaScript is also running, and just use it there. So one code runs everywhere. And since you said there, this Clojure thing can run on the backend and also as a JavaScript compiled to language. Do you know of such use case? Do you have anything to say?
Yes, so there are mechanisms to share code between the client and the server if you're using Clojure. However, that requires full investment in the Clojure script, obviously. I know there are some Leiningen plugins which allow you to have two folders for every project, one with Clojure script, one with server-side Clojure, if you like. So yeah, it's doable, and I do think people use it. We still aren't that invested in Clojure script to do that.
Hello. What are the bad parts of Clojure script and Clojure, and what are the use cases when not used?
Well, the bad part's probably debugging, because once you get a stack trace out of Clojure, because it's compiled to Java, it's terrible. So you have to resort to different mechanisms like just REPL, inspecting stuff, printing stuff around, and logging, which is far from ideal, obviously. That's definitely one of the huge pain points, and I think that's definitely one of the things they're currently working on, to make that whole thing a bit better. I mean, other than that, it's hard to sell it to people because it's a Lisp and it has parentheses, and people just quit at that point. But it's a general purpose programming language, same thing you'd use Python for, Ruby or whatnot. There's no reason to not use Clojure, especially with the entire JVM underneath.
Okay, one more short question. Okay, thank you for the talk. You mentioned parallelism. I'm curious, what are you using? What are you relying on? Are those heavyweight threads and then something like software transactional memory, or what have you in Clojure for that?
So yeah, I mentioned we were a bit lucky, so we got away this time. So we had a completely parallel problem. So we basically spawned one thread per job, and that's it. Those threads just sync later to the main thread just to notify the consumer about their success or failure. And for that, we use just inter-process communication capabilities of 0MQ to just notify. But other than that, that's it. Just plain old thread.
Okay, thank you, Nikola.